A production line is a set of sequential operations established in a factory where components are assembled to make a finished article, or where materials are put through a refining process to produce an end product that is suitable for onward consumption. Typically, raw materials such as metal ores or agricultural products such as foodstuffs or textile source plants like cotton and flax require a sequence of treatments to render them useful. For metal, the processes include crushing, smelting and further refining. For plants, the useful material has to be separated from husks or contaminants, and then treated for onward sale. Early production processes were constrained by the availability of a source of energy, with windmills and water mills providing power for the crude heavy processes, and manpower being used for activities requiring more precision. In earlier centuries, with raw materials, power and people often being in different locations, production was distributed across a number of sites. The concentration of numbers of people in manufactories, and later the factory as exemplified by the cotton mills of Richard Arkwright, started the move towards co-locating individual processes. With the development of the steam engine in the latter half of the 18th century, the production elements became less reliant on the location of the power source, and so the processing of goods moved to either the source of the materials or the location of people to perform the tasks. Separate processes for different treatment stages were brought into the same building, and the various stages of refining or manufacture were combined. With increasing use of steam power and increasing use of machinery to supplant the use of people, the integrated use of techniques in production lines spurred the industrial revolutions of Europe and North America. Thus, from the processing of raw materials into useful goods, the next step was the concept of the assembly line, as introduced by Eli Whitney. This was taken to the next stage of the Ford Motor Company in 1913, where Henry Ford introduced the innovation of continuously moving the cars being assembled past individual workstations. This introduced the idea of standardization. The assembly line was a contraption of many chains and links that moved to place different parts into various places throughout the car. The chassis of the car was moved along the 45-meter line by chain conveyor, and then 140 workers applied their assigned parts to the chassis. Other workers brought additional parts to the car builders to keep them stocked. The assembly line decreased the assembly time per vehicle. The production time for a single car dropped from over 12 hours to just 93 minutes. An assembly line is a manufacturing process, often called a progressive assembly, in which parts, usually interchangeable parts, are added as the semi-finished assembly moves from workstation to workstation, where the parts are added in sequence until the final assembly is produced. By mechanically moving the parts to the assembly work and moving the semi-finished assembly from workstation to workstation, a finished product can be assembled faster and with less labor than by having workers carry parts to a stationary piece for assembly. Assembly lines are common methods of assembling complex items such as automobiles and other transportation equipment, household appliances, and electronic goods. Workers in charge of the works of assembly line are called assemblers. Assembly lines are designed for the sequential organization of workers, tools or machines, and parts. The motion of workers is minimized to the extent possible. All parts or assemblies are handled either by conveyors or motorized vehicles, such as forklifts or gravity, with no manual trucking. Heavy lifting is done by machines such as overhead cranes or forklifts. Each worker typically performs one simple operation unless job rotation strategies are applied. According to Henry Ford, the principles of assembly are these. 1. Place the tools and the men in the sequence of the operation so that each component part shall travel the least possible distance while in the process of finishing. 2. Use work slides or some other form of the carrier, so that when a workman completes his operation, he drops the part always in the same place, which place must always be the most convenient place to his hand, and, if possible, have gravity carry the part to the next workman for his own. 3. Use sliding assembling lines by which the parts to be assembled are delivered at convenient distances. Designing assembly lines is a well-established mathematical challenge, referred to as an assembly line balancing problem. In the simple assembly line balancing problem, the aim is to assign a set of tasks that need to be performed on the workpiece to a sequence of workstations. Each task requires a given task duration for completion. The assignment of tasks to stations is typically limited by two constraints: a precedence graph which indicates what other tasks need to be completed before a particular task can be initiated, e.g. not putting in a screw before drilling the hole, and a cycle time which restricts the sum of task processing times which can be completed at each workstation before the workpiece is moved to the next station by the conveyor belt. Major planning problems for operating assembly lines include supply chain integration, inventory control, and production scheduling. Consider the assembly of a car. Assume that certain steps in the assembly line are to install the engine, install the hood, and install the wheels, in that order, with arbitrary interstitial steps. Only one of these steps can be done at a time. In traditional production, only one car would be assembled at a time. If engine installation takes 20 minutes, hood installation takes 5 minutes, and wheels installation takes 10 minutes, then a car can be produced every 35 minutes. In an assembly line, car assembly is split between several stations, all working simultaneously. When a station is finished with a car, it passes it on to the next. By having 3 stations, 3 cars can be operated on at the same time, each at a different stage of assembly. After finishing its work on the first car, the engine installation crew can begin working on the second car. While the engine installation crew works on the second car, the first car can be moved to the hood station and fitted with a hood, then to the wheels station and be fitted with wheels. After the engine has been installed on the second car moves to the hood assembly. At the same time, the third car moves to the engine assembly. When the third car's engine has been mounted, it then can be moved to the hood station. Meanwhile, subsequent cars, if any, can be moved to the engine installation station. Assuming no loss of time when moving a car from one station to another, the longest stage on the assembly line determines the throughput, 20 minutes for the engine installation, so a car can be produced every 20 minutes, once the first car taking 35 minutes has been produced. Before the Industrial Revolution, most manufactured products were made individually by hand. A single craftsman or team of craftsmen would create each part of a product. They would use their skills and tools such as files and knives to create the individual parts. They would then assemble them into the final product, making cut and try changes in the parts until they fit and could work together. Craft production. Division of labor was practiced in China, where state-run monopolies mass-produced metal agricultural implements, China, armor, and weapons. Centuries before mass production appeared in Europe on the eve of the Industrial Revolution. Adam Smith discussed the division of labor in the manufacture of pins at length in his book The Wealth of Nations, published in 1776. The Venetian arsenal, dating to about 1104, operated similar to a production line. Ships moved down a canal and were fitted by the various shops they passed. At the peak of its efficiency in the early 16th century, the arsenal employed some 16,000 people who could apparently produce nearly 1 ship each day and could fit out, arm, and provision a newly built galley with standardized parts on an assembly line basis. Although the arsenal lasted until the early Industrial Revolution, production line methods did not become common even then. The Industrial Revolution led to a proliferation of manufacturing and invention. Many industries, notably textiles, firearms, clocks and watches, horse-drawn vehicles, railway locomotives, sewing machines, and bicycles, saw expeditious improvement in materials handling, machining, and assembly during the 19th century, although modern concepts such as industrial engineering and logistics had not yet been named. The automatic flour mill built by Oliver Evans in 1785 was called the beginning of modern bulk material handling by Roe, 1916. Evans' mill used a leather belt bucket elevator, screw conveyors, canvas belt conveyors, and other mechanical devices to completely automate the process of making flour. The innovation spread to other mills and breweries.